Good afternoon to you. Mark Sott of HurricaneTrack.com here with your Hurricane Outlook and discussion for Monday, June 24th, 2019. Let's take a look real quick. We know there's nothing happening in the Atlantic Basin, and the same is true for the Central Pacific region. However, in the eastern North Pacific, we do have invest area, what is this, 91E or something like that? It's going to be Alvin, it looks like, eventually. 50% chance of development and over the next 2 days, and 70% chance over the next 5 days. The 91E designation is just a way that the National Hurricane Center designates these systems as suspect areas. Trying to get this to, there we go. Instead of just saying this blob of clouds, for example. So they use the numbers 90 through 99 and the letter E for Eastern Pacific. Actually, it's EP, but we just shorten it to E. And the same holds true for the Atlantic. You probably know this, but I'm just recapping it for those that don't. 90 through 99 is the numbering system that are used for this sort of pre-tropical storm phase, the invest phase as we call it, the investigation phase, when something gets the attention of the scientists and the forecasters at the National Hurricane Center and some of the academic and government websites. You think about the University of Wisconsin site, which adds a layer of analysis to these products that we watch, more than just cloud shots. It's just a good way to keep up with what's what. So 90 through 99, the letter E for the Eastern Pacific, L for Atlantic, W for Western Pacific, and so forth. So here it is, this large area. I like to call this sort of the grapevine, this band of clouds that has come together in the last few days here as a active phase of what we call a convectively coupled Kelvin wave has moved through, leaving in its wake this favorability window, sparking development in the Eastern Pacific. I'm going to talk a little bit more about what that is in a moment, a convectively coupled Kelvin wave. But you can clearly see sort of this line, linear shape to the cloud mass here, the intertropical convergent zone, and there's definitely convergence. Convergence is air coming together. And it's coming together and trying to do so in a more organized fashion right about here. And that's where we think this first system of the season in the Eastern Pacific will form. And we can see that from Levi Cowan's website here, Tropical Tidbits, in animation form. Nice line of clouds out here, as I mentioned. And then this is where the energy is trying to bundle well to the south of the Mexican coastline, over the fairly warm waters of the Eastern Pacific. Now, let's get rid of this. This was hinted at just yesterday, I guess, from Michael Ventris, Dr. Ventris, who's done a lot of work on these convectively coupled Kelvin waves. And he mentioned on Twitter that a strong convectively coupled Kelvin wave, or CCKW, passing the Eastern Pacific today. So it's moving through over the weekend, heading in from west to east generally. And that will leave in its wake, usually 1 to 3 days after the passage of this active phase, you get this upward motion and this convergence of air down at the surface and a favorable pattern aloft, and it usually triggers what we call cyclogenesis, or the birth of tropical cyclones. And we can see that coming together here on the vorticity signature right over here. I'll use white just for a moment, just to highlight it better. Come on, Mark. There we are. This is the area here coming together along this line here of energy or convergence, vorticity in the atmosphere. This is about the 5,000 foot level. And you can see right here it's starting to bundle together. And when tropical systems do that, they bundle that energy, they bundle the heat, they develop the spiral banding and so forth that we see on cloud cover shots. And it's off to the races. And it's sitting here about 10 degrees north latitude, right where it should be, right in the wheelhouse for development in the region that we would expect it to do so. And, it'll move off probably to the west-northwest, something like this, and eventually die out over the colder waters of the Pacific. Now, what exactly is a convectively coupled Kelvin wave? Well, I do not have one of my clever analogies that I can just simplify this for you. So let's take a look at a piece here from Carl Schreck from North Carolina Institute for Climate Studies that he put out not long ago. And university, let's see, he did this with North Carolina State University through Asheville, North Carolina. So the climate studies is in Asheville through a partnership with NC State. I gather that's what this means right through here. So what does he say? Well, we can skip the abstract, and let's go down to the introduction here, because this is what I want to talk about. That early tropical cyclogenesis studies recognize easterly waves as the primary precursors for tropical cyclogenesis, especially in the North Atlantic. Those are the tropical waves. These open waves are embedded within the trade easterlies, such that they have no westerly flow on their equatorial side until tropical cyclogenesis. So the wave comes along, you can see it in the atmosphere, and it literally looks like an inverted trough in the trades. You have winds that are coming from the southeast to northwest, and then from the northeast to southwest, but typically no westerly winds coming in to close this off. I'm trying to diagram it here and give you a low pressure area, and that's what he's talking about. So if we go down, I saw this somewhere. Where was it? This first paragraph, I'm skipping around here. So decades after William Gray, long time ago, tropical cyclogenesis remains one of the biggest research problems in our field. Many distinct lines of inquiry have deepened our understanding, and this study aims to bridge two of the most recent ones. All right, and so one of those is this convectively coupled Kelvin wave, and he talks about it more in this paragraph here. They once called these super cloud clusters, but that's not sexy enough, right? So now it's a convectively coupled Kelvin wave, and they used to refer to it as a super cloud cluster. Now it's a convectively coupled Kelvin wave, and they're among the most important synoptic systems in the tropics. And so what they are is generally this energy in the atmosphere that does have this westerly component to it that supercharges over a relatively small area. That's what the word synoptic means. It's not a large-scale area. And it helps to bring in that westerly component and give it a little bit more of a trigger, more so than these tropical waves. And he mentions that here, that these Kelvin waves also modulate tropical cyclogenesis factors like potential vorticity, vertical shear, ventilation, and moisture. So it's like a, I'm reaching here for a good analogy. You've got generally favorable conditions in the tropics with the warm water, the moisture, etc. These convectively coupled Kelvin waves are a fairly large-scale feature in the scheme of things, larger than a tropical wave, but not basin-wide or a larger feature like the Madden-Julian oscillation. It's a 1 to 3 day event, roughly, and it leaves this period of fertile ground behind. It's kind of like, here's a good analogy. It's kind of like the tractor going along in the field spreading fertilizer, I guess, is the best way to put it. And in its wake, you have fertile ground. All right? That's the best way that I can describe this. And you see that where I've highlighted that these Kelvin waves modulate, or in this case, make it more favorable, the tropical cyclogenesis parameters. I'm paraphrasing here, like the potential vorticity, and we can see that right here. There it is. The Kelvin wave has moved through this region, and the vorticity left behind is enhanced, modulated, enhanced, synonymous there generally. And the vertical shear, better, the ventilation's better, and the moisture's better. So it does. It comes along and kind of says, sprinkling fairy dust to just get kind of crazy with it, and says, okay, voila, you now have a fertile area of which to grow from. And it's, you can measure these in different ways. Dr. Ventris could talk about this more. We had him on, I guess it was last year. I was doing these sort of phone a friend Skype interviews where we brought Dr. Ventris on to discuss these. But you see it in different charts, and you can see it reacting in the atmosphere. And sometimes they trigger development, but they don't have to. But anyway, this one's going to, and it'll eventually move on into the Atlantic, but it's going to encounter generally sinking motion and dry air to counter this favorability. So the Kelvin wave alone is not enough. That's what's important about this. We already had these precedents. What's the word I'm looking for? Trying to think, is it antecedent? No, that would be... We already had pre-existing conditions that were favorable in the Eastern Pacific. No Saharan air layer, no dry air. I won't say none, but then you brought this convectively active Kelvin wave across, plus the energy that was already starting to fester from the intertropical convergence zone. Bam, we're going to get development. As this moves into the Atlantic, because conditions are so overwhelmingly negative, mainly because of the dry air, the Saharan air layer, you can forget about it. Not much enhancement is going to take place. I spent a lot of time on this, but it is very interesting, and as the season goes on and the Atlantic becomes more favorable, usually latter August, these can trigger an outburst of tropical storms, which eventually lead to hurricanes. So there you go. I did the best I could. Interesting paper, if you can pick out the URL there, the AMS journal. Just, Google Carl Schreck, and that's not like the movie. It's Carl with a C, Schreck with S-C-H-R-E-C-K. Carl Schreck III, and his work on convectively coupled Kelvin waves and tropical cyclogenesis. Read all about it. All right. Something that I know a lot more how to explain. Wow, look at this. This is the sea surface temperature anomaly update for today. And again, let's use the white color here. So a few interesting things going on that I want to point out. This has updated today on the 24th. You can clearly see that right there. All right. Down here in the equatorial Pacific, a few more of these blue islands are showing up, if you will, in the surface temperatures. Large dent being put in the El Nino Southern Oscillation. But look closer. In fact, I'll help you look closer. Let's zoom in and just look at the pixels through here right along the equator. You got the blue, and then yellow, some blue, more blue, yellow, yellow, some orange in there. But look at how I'm tracing this. You get this outline here. That water temperature regime is pretty close to average. Those pixel colors being yellow are the first of the gradient, if you will, right here. See? Right there? Highlighting it in white, but you see that right there. And so we're really developing, it looks like a snake, and it does this every once in a while. We saw this develop in 2017, definitely at the, and I think it was 2016 this came on. Of course, 2017 we developed a full-on La Nina. But the bottom line, this El Nino is going away. In fact, I think the data from the CPC, the Climate Prediction Center, for today's update showed the INSO 3.4 value, which is, let's see, roughly somewhere in this box in here, something like that. What's the average sea surface temperature in there? It's down to about 0.5 degrees Celsius. So it's right at the threshold for El Nino, the bottom end. So it is a very, very weak El Nino event. And you can see as plainly as I can that the equatorial Pacific is definitely not overwhelmingly warm. Look at the North Pacific up here, even off the Baja, a little bit colder than average. Why you've got this warming pattern going on, strangely enough, near Hawaii and way off to the northeast. So we'll have to watch Hawaii, see what's happening out there. Also, in the Atlantic, a little bit of cooling going on here at the equator. Not sure exactly what that means. Saw some people talking about it. Maybe it would help to strengthen the West African monsoon, which ejects these tropical waves off. I saw some more tweets about how high the precipitable water values are over Western Africa through the Sahel, and that leads to stronger tropical waves, perhaps, once we get especially into latter August. But for now, most of the tropics down here, right at or slightly above the long-term average. Nothing overwhelming or alarming. We don't see any 2-3 degrees Celsius anomalies like that. There's a few oranges sprinkled in there. So, on average, it looks like it's about 1/4 to 1/2 degree Celsius above average, perhaps. Generally speaking, though, right where it should be. More important is none of this blue color, cold anomalies, is showing up of any significance down in the deep tropics. In fact, it's up here in the subtropics. I'll put an S there. And the warmth is down here in the tropics. So you have this colder over warmer pattern, and typically that leads to a fairly busy hurricane season. We'll see. It's only late June. We have a long ways to go. Now, this is, I think, more important, the upper ocean heat content. All right? And that is the measure below the surface of how much energy is in the ocean, not just at the surface. There's 10 degrees latitude right there, and you can see, it's gaining. And I'm going to outline it here in white. That whole area and points south and west all the way back to the Caribbean, very warm. The water's warm, and that warm water is extending fairly deep. And if we compare that to this time last year, it is quite a marked difference. See that? Especially, look down here. Wow. I just noticed that. Especially down closer to the 10 degree, down in the heart of the tropics there, the main development region. Quite a difference overall. So we're running a bit above what we saw this time last year, for what it's worth. And we're going to have to wait probably another 45 to 60 days before we find out what does it mean. Again, it's like having a well-stocked, and here's a great example. I'll throw my sports analogy in. NBA basketball, the Pelicans got a great draft pick with Zion Williamson, and he said this is going to shock the world. And being a Duke fan, sad to see him leave Duke. Wish he could have stayed, but so be it, right? Now that he's with the Pelicans, the potential is there for him to develop, for the team to develop. Maybe they become a title contender one day. I don't know, right? But the stage seems to be set. Injuries could happen. Anything could go on. Problems with the coaching staff. And this is true for any team sports. Baseball, hockey, basketball, football, NFL season not too far away. You think about loaded teams. Oh, man, that team's looking really healthy this year. College football. Now, whether or not it has anything to do with meteorology, well, no, but the analogy is the same. You have what seems to be a winning combination, but then something happens that's unexpected or even unexplainable, that you just can't explain. And the Atlantic seems to be poised for a regular active season as opposed to inactive, but whether or not it actually holds up to that, I simply don't know, and nobody does. People can maybe express their opinions, but we don't know for sure. But this look right here, compared to last year, a lot more warmth in the ocean, especially at depth. And that's something to keep an eye on going forward. All right, tonight at 8:30 Eastern Time, 9:30 Eastern Time, 8:30 Central, I will be appearing on the WeatherBrains Net Show with James Spann et al. A great production. If you've not tuned into this in the past, well, now's a good time to. This evening I'm going to be talking about the documentary, Tracking the Hurricanes 2018. If you haven't seen it, I put a little featurette on YouTube today discussing how I put the music together for this year's documentary. So if you haven't seen that, check it out. This is, of course, available on Amazon Prime Video. Just search Tracking the Hurricanes 2018. And like I said, though, tonight, 9:30 Eastern, I'll be on WeatherBrains. We use Google Hangout, and I'm able to chat. You see me, and I'm going to show the trailer and a couple of clips and a little bit more background information on it. And it's always fun to be able to chat with the group there. Very well done, and I appreciate being able to be on the program. Tonight, I'll post the link. It's not something you can just click on and it works right now. They set it up, and so you can either follow WeatherBrains on Twitter, or I will post the link on my Twitter feed once they send it to me. All right, WeatherBrains tonight. Real quick, tomorrow I'll do an update in the early afternoon, and then I am heading to Rodanthe along the North Carolina Outer Banks, where I'm going to go and do some work on our nest cam that we have out there on one of the houses that has sort of been lent to us, if you will, as our own private hurricane lab. A real nice family out there, allowing me to put a nest cam and weather equipment when something brews up out that way. It's real close to the Rodanthe Pier, actually. We have a Nest Cam out there, and I've got to go and reposition it to a better spot, so forth and so on. And I'm going to do that tomorrow. I'm going to drive up there tomorrow, spend tomorrow night at the house, and then head home Wednesday afternoon. But I'm going to test something on YouTube Live. I'm going to stream the whole way up there, from here, Wilmington to Rodanthe. And I'll tell you all about it while I'm testing it. I'm trying something new that helps to keep the apparatus cooler. It's a long story. Tune in tomorrow, you'll find out. But anyway, I'll be streaming live tomorrow when I leave, and it'll be on YouTube, the public YouTube stream. And I won't be able to monitor the chat because I'll be driving, and that's not legal. But you can certainly chat amongst yourselves, whatever. And when I stop for food or gas, I can peek in and see what you guys are talking about. All right, so that'll be sometime tomorrow afternoon. It takes me about 5 or 6 hours. No hurry. I get there when I get there, but I'm trying to test something to see if it works to help keep the stream running even when the vehicle gets hot. Let's just say that. All right? So that'll be tomorrow. Thanks for tuning in today. I appreciate your time and attention from your side of whatever device you're watching and listening to me on. I'm Mark Sudduth, HurricaneTrack.com. I'll talk to you again tomorrow afternoon.